In this example, we'll try to find the inverse Laplace transform of this given function. So we have given here as function of s as what, 3 over s to the power 4. So we just want to figure out what is the function of t, right? So that is the inverse Laplace transform of this capital F of s, or let's say our goal is to figure out the inverse Laplace transform of 3 over s to the power 4. So let's try to see how can we do that. So over here we have to find the inverse Laplace transform of 3 over s to the power 4, and then I'm going to do that. To find the inverse Laplace transform of these, we want to figure out, we want to use the table of Laplace transform, and then by using that we just try to manipulate little bit and then try to figure out the inverse Laplace transform of given function. So if you look into the the table of Laplace transform, there is a function given on, generally on function given in one column, and its corresponding transform is given on the other one, right? So what you need to look for right now is which one somehow on the transform column, let's say which one resemble like something like 3 over s to the power 4. Okay, if you look into, like, scan through over there on the table of Laplace transform, you should be able to see one of the formula, or let's say the Laplace transform. Okay, Laplace transform of t to the power n is given as n factorial over s to the power n plus 1. So when I compare over here, this actually somehow resemble like this transform. So if that is the case, inverse Laplace transform of this could be that one, right? So I want to go in the backward kind of direction. So I want to apply this technique over here. Okay, so if I want to apply this as a kind of the Laplace transform formula, it can give you that the inverse Laplace transform of n factorial over s to the power n plus 1 is actually t to the power n, right? So that's how the inverse Laplace transform works. So if Laplace transform of t to the power n is that, then the inverse Laplace transform of this should be t to the power n. So that's how it works. So if that is the case, I want to assume that this is like kind of my formula, and I want to apply. Okay, so if that is the case, you can compare between these two over here. But how do we compare here, right? So it's not exactly similar like this, because okay, we have some number at the top. So n factorial is some number, so we have that number. And then over here at the bottom we have something else. We have s to the power n plus 1 over here on the formula. We have s to the power 4. So if you compare, they have the same base, s and s. And then if you kind of look into it over here, we get n plus 1 at the top, over here 4. So generally, if you want to apply this formula, try to look into the bottom one, and then the number can be manipulated later on by multiplying by some number to the top, bottom, or something like that. But just want to make sure that this is actually matching, because to balance these would be kind of a little bit tough. Okay, so what I want to do here is just try to compare here the base here. So right, so we have over here on the base s to the power 4, we have s to the power n plus 1. If they are same base, same function, let's say, and then what should be the value of n here? So the 4 can be viewed as what, 3 plus 1. So if you view in that way, we know what is the value of n, right? So if you just directly compare, the value of the n must be 3, right? Or how you want to compare or view, you can definitely get that the the value of the n is 3 over there. That's what we can detect. So if that is the case, right, so let's view our function, this 3 over s to the power 4, right, as this way. So at the bottom, at least we can view this as s to the power 3 plus 1, right? So if I view in that way, so if I want to use this formula over here, it would be nice if I have at the top kind of n factorial. That means over here it would be nice if we would have what, 3 factorial over here at the top. Then we could actually apply this formula over here of t to the power n. But we do not have that kind of thing, because they are not same, right? So over here these two are not same, because the bottom is s is same, but the top, I need 3 factorial. What I have here is 3, but this is just a number. I can manipulate here little bit, right? So Of course this need to be same even its number, but let's try to see what will happen. Okay, so I need 3 factorial. 3 factorial means what? 3 factorial means 3 times 2 times 1, right? So which means 6. What I have here on the problem is 3, what I needed is 6. How can that happen? If actually I multiply by what, 1/2 over here to this 3 factorial, right? So we'll have 1 over 2 times a 3 factorial, which means what, 3 times 3 factorial means 3 times 2 times 1, and then which means 6. So 1/2 means 6, 1/2 times 6 means 3. So that's exactly over here what I have at the top, right? So 3 over s to the power 4, that can be, let's say it in this way, 3 over s to the power 4 can be manipulated in that way. But what is the benefit of that manipulation? If you actually write down in that way, now you can see here, to figure out the inverse Laplace transform of 3 over s to the power 4, we can just find the inverse Laplace transform of this expression, which is 1 over 2, which is a constant, multiply by this. So if that is the case, the constant can be taken out and just figure out the inverse Laplace transform of 3 factorial over s to the power 3 plus 1. But what is the benefit of doing that? 1 over 2 is just a constant, but 3 factorial over s to the power 3 plus 1 you can directly compare with this one, and then you get the value of the n is exactly 3. It's matching to the top to the bottom, right? So if that is the case, I mean, we know the value of the n is 3, so t cube should be the inverse Laplace transform of 3 factorial over s to the power 3 plus 1, or let's say s to the power 4. Then the function that we get over here, 1/2 t cube, is the inverse Laplace transform of 3 over s to the power 4. Okay, let's try to see a couple of similar example over here and then see if we get at least one more example and then see if we get this one. For example, let's say if our goal is to figure out the inverse Laplace transform of, let's say, 2 over s to the power 5. Okay, then how do we work? So it seems like we definitely want to use this formula again over here, but if we want to use that, we just want to have exactly kind of a similar kind of expression, which we do not have here, because if you look into the 2 over s to the power 5, right, 2 over s to the power 5, the bottom is s to the power, we can say 4 plus 1, so we could assume the value of the n is 4, but at the top we just have 2. We needed what? To match up this perfectly, we needed 4 factorial. Okay, why don't we just randomly let's assume that we have 4 factorial. We could just assume that, okay, here we have 4 factorial, but 4 factorial is not 2, right? So 4 factorial means what? 4 times 3 times 2 times 1, so that means 4 times 3 is 12, 12 times 2 is 24, but we have 2 here, so we needed 24. What is missing? Is 12 over here, right? So we need to multiply by 12 to the top or bottom, or let's say it in this way. If I multiply by 1/2 1 over 12 over here to the 4 factorial, right, and then I will exactly get 2, right? So 4 factorial means 4 times 3 times 2, and then we have at the bottom of 12, something like that, and then 4 times 3 cancel out, 3 cancel out, so we exactly get 2 over here. So what I'm trying to say here is, rather than now figuring out the inverse Laplace transform of 2 over s to the power 5, we could see this alternative kind of format over here, which is same function, but I've just tried to manipulate this and then write down this as 1 over 12 times 4 factorial over s to the power 4 plus 1. If I do that, 1 over 12 is a constant. I just need to find the inverse Laplace transform of 4 factorial over s to the power 4 plus 1, which if you compare with this one over here, then you get the value of the n exactly matching. The top is matching, bottom is matching for n equal to 4. So if that is the case, this should be 1 over 12 t to the power 4 should be the Laplace transform, inverse Laplace transform of 2 over s to the power 5. I hope by looking into these two examples, it makes sense for how to find the inverse Laplace transform of similar function over here. And thank you very much for watching this video.